A while back, Snowflake announced that they would be enforcing multi-factor authentication for all users. Pipelines using service accounts, that breaks because they can't use multi-factor authentication. And since Snowflake disabled password authentication without multi-factor authentication, all these pipelines using user and password authentication, they stopped working. Luckily, the fix is rather simple. Namely, we switch to private public key pairs. And in this video, I'm going to show you how to set up those public and private key pairs. I'm going to show you how to generate a public and private key pair, how to add a public key to a Snowflake user, and how to base64 encode them so that applications can use it. So let's first start with generating a private key. To generate a private key, I'm going to use the OpenSSL CLI. I'm going to pick RSA as my algorithm. My output file is going to be my private key file, and I'm going to choose for 2048 bits. Hitting enter just generates that. We can look at it by catting the output, and we see that it's a pretty big file. Fine, that's step one. Next up is generating a public key based on the private key. I again use the OpenSSL CLI. My input is going to be the private key, and the output is going to be the public key. And again, we can print that out, and it looks like this. That's a bit shorter. For Snowflake, we now have enough. The only thing we have to do is create a user and add public key to the user account. So let's do that. Here I am in Snowflake, and to create a new user, we can just run this SQL query. The SQL query is a create user command. We give it the name of the user. In this case, I'm just going to call it service user. The type is going to be service, which indicates that it's not a human person. And lastly, we have to add in our public key. So let's get that from the terminal and copy paste that in here. I'm going to show you a neat little trick you can use if you use bat as your CLI, which is what I do. So first, by using the -p flag, we can make sure that we only print the plain version of it. So no line numbers, no highlighting. And adding the R flag, we can specify which lines we want. If we scroll up a bit, we see that we want lines 2 to 8. So that's what I'm going to put in. Neat. So now we have everything that we need. And to put it directly into the clipboard, I'm going to pipe this into pbcopy. Back to Snowflake, I can put it into the RSA public key, hit enter, and my service user is successfully created. So now we have a Snowflake user that has a public key, and the only thing left for us to do is give every application that needs it the private key. Now for dbt specifically, it wants a DER encoded private key, which is basically a binary version of our private key. So let's generate that. With this command, I'm going to tell OpenSSL that my input key is PEM, which is correct, namely this file that we generated earlier. The output file is going to be DER, which is an encoding. And this is going to be the name of that file. So let's generate that. And we could print it, but my cat command is just going to show this as binary. And the last part is that we have to base64 encode this specific value. And we can do that using the base64 CLI. We're going to pass in the DER file, and we're going to output the base64 file. And this is something that we can print. Nice. Now if we go to the dbt docs, and we scroll down to key pair authentication, we see that we have two options of providing this key. First is a path, so you can just point it to the base64 encoded path, or alternatively you can use the private key and just paste in the base64 encoded value. And of course, in dbt you can also do this with environment variables, which is what I would advise. Now Dagster actually wants an encrypted private key instead of a DER encoded private key. To do that, we again use the OpenSSL CLI command. We're going to tell it that our input file is the same private key that we originally generated all the while back. We're going to tell it that we want to AES encrypt it. Our out file is going to be this one. And lastly, we have to provide a password. There we go. Now our encrypted private key has been generated. And same as for dbt, we can just simply base64 encode this. And if we go to the Dagster documentation for the Snowflake integration, we see that for the Snowflake resource, we can add these two environment variables so Dagster can read them. For the private key, we're just going to paste in the base64 encoded value, or again, use environment variables. And for the private key, we use the password that we chose. And that's it. That's how you can connect to Snowflake using a public and private key pair. If you have different applications that want a different variation of the private key, just consult the documentation. You can use the OpenSSL CLI command to just convert the private key into any format that you like. Happy snowflaking!